Welcome to Mrs. Moan's Math Videos. We are working on target number 5, prime factorization. Hopefully you have a pencil and a paper to take some notes, and then we're going to do some practice problems at the end. So here we go. First one we're going to try is the prime factorization of 360. There's two ways that we've been doing it. One is making a factor tree. So that's how we will start here. I apologize for my writing. It is so sloppy on an iPad. I'm getting used to it with my gigantic finger, so bear with me. So 360, first thing we do, we think of a factor pair of 360. You can use any one that you'd like. You could use 2 times something. It looks like 5 goes into it, 3 goes into it. I'm going to actually use 10 because I know it ends in a 0, and that's kind of an easy one for me to think about. So 10 times 36. Next, you look at it and you have to find out if it's a prime number. If it's a prime number, 10 or 36, then you circle it. If it's not, you keep factoring it out. So neither one of them are prime. Break 10 into 2 times 5. Right away, deal with those numbers. 2 is prime, so right away you want to circle it. 5 is also prime, so you need to circle it. Next, go back to 36. Factor that into, you could do 2 and 18, 3 and 12, 4 and 9, 6 and 6. It does not really matter. You'll end up with the same result. I'm going to go with 6 and 6. 6 is not prime, so I have to keep factoring it. 2 times 3. Right away I notice 2 and 3 are prime, so I'm going to circle them. And go back to your last 6. We're going to break that into 2 times 3. And again, those are both prime. Circle, circle. And once you have everything at the bottom circled, you know you are done. So, final piece of this, you need to write it using exponents. So I'm going to count how many 2's I have here. 1, 2, 3. So you write 2 to the 3rd power, since there are 3 of them. Next we go to 3's. There's 1, 2 3's. So we write 3 to the 2nd power, and there's 1 5 right there. So my final answer should be written that way. One thing to look out for, just make sure you never use a 1 in your prime factorization tree. Here's an example. Like, let's say we're starting over here, and we add our 360 and then 10 times 36, and you wanted to try breaking this into 1 times 10. You can't do that. You'll keep going forever. And when you look at this 1 right here, it is not a prime number, and it is not a composite number. So never, never, never use a 1 in your prime factorization. Our second thing we're going to do is a factor tower. We're going to continue using 360 as our example. So what a factor tower would look like, you're going to start with the 360 on top like usual, and you're going to make an upside down division sign. And then with this, it's kind of like your, well, we haven't gotten to GCF yet. Never mind. You want to factor out only prime numbers on the side over here. So here's what I do just to make sure I don't screw up. I write down the first 4 prime numbers over here on the side and think that really those are the only ones I'm going to be factoring out. So I know that 360 can be divisible by that 2 right there. So you think of it as a division problem. 360 divided by 2 is 380. Or sorry, 180. Do another division sign upside down. 2 goes into this as, again, 2 is my prime number. 180 divided by 2 is 90. You keep going until you have a 1. I like to think of it as 1 and done. So keep going until you have a 1 at the bottom. 2 goes into it again. 90 divided by 2 is 45. This time you can use 3 or 5. Both go into it. Might be easier to do 5. That's kind of a easy one to think about. 9 is still not prime, so I can keep factoring it out. And 3, oh, you still need a prime number out here, and it actually would be 3. So 3 divided by 3 is 1. 1 and you're done. This is good. So now here's what's cool about this. You can have your prime factorization all on the outside right there. It's all organized. You still do need to rewrite it over here on the side though. So if you count, there's 2 3's, so 2 to the 3rd, 2 3's down there, 3 to the 2nd, and then your 5. So again, there's your prime factorization. If you ever heard of Why the Chicken Crossed the Road, well, here's 2 really kind of stupid chickens. Check them out. Ha ha ha. Okay, let's do some more. So here's where you're going to want to do these on your paper. Pause it, and then when you're done, come back and check your answers. Prime factorization of 50. Let's start with our factor tree first. You could do 2 and 25. Right now I'm going to do 5 and 10. And I notice 5 is a prime number. Circle it. 10 is not, so I keep factoring it. 2 times 5. Right away I know 2 is prime. Circle it. 5 is prime. Circle it. I quickly check. Did I use any 1s? Nope. Good thing. And then you want to finalize your prime factorization down here at the bottom. 1, 2, and 2 5s. There is my final answer. Good way to check. 5 times 2 equals 25, and 25 times 2 equals 50, and that's what we wanted it to equal. If you want to use the factor tower, this is what it would look like. Again, I like to write the first 4 prime numbers over here to make sure that's what I'm using on the outside of my tower. 50 divided by 2 is 25. 5 is the prime number that I can factor out. And then 5 divided by 5 equals 1. 1 and I'm done. So my prime factorization is right there. And then you just rewrite it, just like we did with the factor tree. There's your final answer. Let's check 288. I think I'll use the tower for this. This looks probably going to be a lot of factors here. Start with 2. Can do 2 again. It's really easy when they're even numbers. You know 2 goes into it. 144 divided by 2 is 72. It's even, so 2 again. 72 divided by 2 is 36. 2 goes into that. 36 divided by 2 is 18. Oh, I'm going to run out of room down here. Alright, how am I doing? 2 does not go into that. The next prime number would be 3. 9 divided by 3 is 3. And the last one I can do is 3. 3 divided by 3 is 1. 1 and I'm done. Let's check out our prime factorization. It's huge. Alright, so how many 2's do we have here? 1, 2, 3, 4, 5. So 2 to the 5th power times, there's 2 3's. That's a little time sign. 3 to the 2nd. Final answer, I did not use any 1's. That is good. And I'm going really fast here too, so feel free to watch this a few times if I am talking too fast. The very last one we have is 17. So if we do a factor tree of 17, try to figure out what times what is 17. I'm going through all the divisibility rules and I cannot find anything except 1 times 17. And now you're right, I told you to never use a 1 in your prime factorization. So here's what you have to do. If you find out that your number that you used is a prime number, then all you need to do is write the actual number down. So your final answer is just 17. It's kind of weird, but that's what the answer would be. All right, good luck to you. If you need more help, always come and see me. All right, and remember, why the chicken crossed the road. Okay, bye-bye.